I realized that I did not include any transformation of graph problems on the Unit 2 review sheet for Math 1111. So I've pulled together about 5 examples that I'm going to work through. I added this worksheet to the announcement with the videos, and I'm going to provide the answers here in this video. So remember that basically when you're looking at any of your basic functions, whether it's the squaring function, or the quadratic function, the square root, cube root, that there are basically 4 different players, if you will, in the problem that can cause about 6 different transformations. In general, you have something like f of x equals a times bx minus h, and it could be squared, plus k. Or you could have f of x equals a times the square root of bx minus h added to k. Okay, and so you've got to remember what each one of those letters do, and it's pretty much consistent across the board. And I'm going to kind of run through it pretty quickly. You should have that in your notes from one of the lectures prior to the class suspension. If you'll remember, the letter A really tells us 2 things. If we look at the sign of A, that tells us whether or not there is a reflection on the x-axis. If A is negative, there is a reflection on the x-axis. We focus on the number or the numeric value, and that tells us whether or not there is a vertical stretch, or I think they use the word compress. We call it a stretch or a shrink. Remember, if A is bigger than 1, it's a stretch. If it's less than 1, it is a compression or a shrink. Letter B, again, has 2 purposes. Its sign tells us whether or not there is a reflection on the y-axis, and the number tells us whether or not there is a horizontal stretch or compression. But remember, none of the examples we've done and none of the problems on the test have a horizontal stretch or compression. The letter H tells us whether or not tells us about the horizontal translation. Again, that's going to be whether it's moved left or right. And remember, it is backwards or opposite of what our brain would tell us. And then finally, K tells us about the vertical translation, whether the graph is going to go up or down. Okay, so you have to be able to look at the equation and tell me all the different things that are going to happen. When we worked these examples in class, we did it in a table format, and so you may want to use that same table format. We identified the vertical translation, the horizontal translation, whether there was a reflection on x, whether there was a reflection on y, and whether there was a vertical stretch or shrink. Remember, we're not going to deal with horizontal stretch or shrink or compression. Okay, so one of the things that may help you as you're working through these problems is to identify these different pieces. Remember that A is always the number out front, B is inside with the X, H is the constant inside, and K is typically tagged at the end. So if I'm looking at this first problem, okay, and I start with the vertical translation, which is determined by K, I can see that this is going to go up 4 units. My horizontal translation is controlled by H, and to ensure that I don't make a calculation error or a wrong direction error, I'm going to take that piece inside the parentheses, x plus 2, set it to 0, and solve for x. By solving for x, I can ensure that I make sure if I'm going left or right. And based on the fact that I get a -2, that lets me know that I'm going to go left 2 units. Reflection on x is determined by the sign of A. Since A is negative, there is a reflection on x. B is not negative, so there's no reflection on y. And A is 1, so there's no vertical stretch or shrink. So in terms of the boxes that I would mark, I would have to mark it went up 4, left 2, and reflected on the x. So I would have 3 answers or 3 boxes marked. Okay, on the second one, again, if we want to think about kind of using our little chart, okay, we have vertical translation, horizontal translation. Is there a reflection on x? Is there a reflection on y? And is there a vertical stretch or shrink, excuse me? Okay. So my problem is f of x equals -1/2 times the square root of x plus 1 minus 3. So again, the number out front is a, b is inside with the x, h is the constant, and k is tagged at the end. The vertical translation is determined by k. In this case, k is -3, so we went down 3 units. Horizontal translation is controlled by H. To ensure that I don't get the wrong direction, I take my equation, my x plus 1, and set it to 0 and solve for x. X equals -1. So again, that's my clue that I'm going to go left 1 unit. Reflection on x is determined by the sign of A. A is negative, so that tells me, yes, there is a reflection on x. Reflection on y is determined by B. It's positive, so there's not one. And then vertical stretch or shrink. In this case, it would be a shrink or a compression because A is less than 1. It has a value of 1/2. So that would be a vertical compression or a vertical shrink. So in that case, you would have 1, 2, 3, 4 different options selected because you have to tell me it went down 3, left 1, reflected on x, and it was compressed. Okay, the third one, f of x equals 2 times the absolute value of x minus 3 plus 1. And again, we can kind of set us up our little table and go through the pieces. We have our vertical translation, horizontal translation, whether or not there's a reflection on x, whether or not there's a reflection on y, and the vertical stretch or shrink. So again, if I identify the players, I always like to do that first. I have A is the number out front, B is inside with the X, H is the constant inside the symbol, and K is tagged at the end. Guys, if you can't remember the guidelines, okay, go back up here to the top. I kind of scrolled them out for you, or they're definitely on the PowerPoint for the lesson on transformations of graphs, and you should have notes on that as well. So looking at this problem, my vertical translation determined by K is +1, so that means we went up 1. My horizontal translation determined by H, I'm going to make sure I don't make a mistake, X minus 3, and I solve for X. So X is +3, which tells me I went right 3 units. A is positive, so there's no reflection on X. B is positive, there's no reflection on Y. A is +2 or 2, so there is a stretch. So it was stretched vertically because A is greater than 1. All right, the fourth one we have the opposite or the negative of the cube root of -x plus 5 minus 2. So again, if I set up my little table, okay, so I have vertical translation, horizontal translation, reflection on X, reflection on Y, and is there a vertical stretch or shrink? Okay, so if I identify my players, remember A is the number out front, B is in front of the X, H is inside as the constant, and K is tagged at the end. My vertical translation is determined by K. It's -2, so we go down 2 units. My horizontal translation is controlled by H. Guys, be super duper careful because you have -x plus 5 equals 0. I need to solve for X. So 5 equals X. So it's actually positive. So I'm actually going to go right 5. A is negative, so there is a reflection on X. B is negative, so there is a reflection on Y. And A is 1, so there's no vertical stretch or compression since A, or the absolute value of A, is +1. There's not a number. It's not 2 or 1/3 or whatever. One more. Okay, we have we have +1/3 times the quantity -x minus 1 to the third plus 2. This is your cubic. Again, you got to be able to tell me the vertical translation, horizontal translation, whether there's a reflection on X, reflection on Y, and whether there's a vertical stretch or shrink or compression, which is the term I believe they use. Okay, so if we identify the players in the problem, A is the number out front, B is in front of the X, H is inside with the X, just the number, and K is tagged at the end. So my vertical translation determined by K is up 2 because it's positive. Again, guys, be super careful making the horizontal translation decision. We have -x minus 1 equals 0. Again, if I solve that for X by adding X to either side, I have -1 equals X, which means I'm going left 1 unit. A is positive, so there's no reflection on X. B is negative, there is a reflection on Y. And my A value numerically is 1/3, which is less than 1, so that would be a compression or a shrink because A is less than 1. I know that was really quick, but you should have some detailed notes on that because I know we covered that lecture prior to the class suspension.